So when constructing hyperbolic graphs, we need basic equations. Okay, for example, exponential equations. From your metric mathematics, you know that half a base to the power x, it's an exponential graph. It moves upward like that, the black one, from your grade 12 prior knowledge, which is the same graph with half e to the power x going upwards. Okay, so if we reflect the black graph along the y, reflection along the y, we are going to put a negative on the exponent x, a negative. We are reflecting along the y, then we get the green graph. Okay, so we have reflected the black graph. By reflecting, we obtain the green graph. Okay, and remember the intercept is half. Okay, half here. Also the intercept here, when x is 0, it's half. When x is 0, y is half. Okay, because any number to the power 0 is 1. Okay, so from there now we want to reflect, okay, the green one along the x. Okay, if we reflect the green one along the x, what do we get? We are reflecting along the x, so we are going to get this orange graph. Okay, that will be along the x, we reflect this green one, which means it will be negative now. Y is downwards, negative y. That one is a positive y. Positive y, but the x has been reflected, which means it's going in the negative direction. This one in the positive x direction. Okay. So we construct hyperbolic graphs or hyperbolic functions by adding these exponential graphs. If you add that and that one, you obtain sin h x, okay, cos x. So sin hx and cos x. So that one is your cos x. Okay, this one is your sin hx. Okay, so you constructed by adding the two graphs. Which graphs did you add? You added this one plus that one. You obtain this. You added the green one plus the black one. We obtain the red graph, which is the cos x. Okay, so this one is the sin hx of, okay, hyperbolic sin h, cos x, and tan hx. They always add an h here. You always add an h for hyperbolic. So we are going to sketch again the other one for tan. Okay. Okay, so that is the graph of tan hx. Okay, tan hx. That is the graph of tan hx. How do we find that one? Simply sin x over cos x. And don't forget that tan hx now has an asymptote at y equal to 1 and y equal to negative 1. Okay, those are the asymptotes. So it's undefined at y equals to negative 1 and an asymptote at y equals to 1 and negative 1. Okay, so at this point it's undefined, That is our tan x. So in summary, hyperbolic graphs are obtained by adding these exponential graphs. Okay, so we are saying e half e to the power x plus a negative half e, which becomes negative, to the power e to power negative x. So if you add the two, we obtain that sin hx graph. If you add the two graphs, this one plus that one, we obtain the cosh x graph. Okay, so these are just the basics. Okay. So don't forget your basic metric mathematics, that this E can be represented as a base B or A or any number. A, B can represent that E. E, it's a number. Okay, E is representing a number, a number. Okay, so don't forget the concept of reflection. If you reflect in the Y, this positive becomes negative. That is the graph. Okay, reflecting the Y, the negative there, sorry, it changes only that. The negative is the one that it changes. If you reflect the graph in the Y, you obtain the green graph. Okay, if you reflect this green graph in the X, okay, what do you get? You obtain this orange graph. Okay, so these are the basics.